Let's get started to talk about persistent data with room using SQLite. SQLite is the standard mechanism for persistent on Android since the first version. This is based in SQL instructions. I think most of you are watching this video knows about that. And the data are organized in tables, columns, records. This quite it's quite very common in SQL databases. So the SQLite has the most features that most databases has, like primary key, foreign keys, indexes, transactions, views, triggers. I think that the only feature that the regular databases has and the SQLite doesn't have is the stored procedures, but I think it's not very useful in mobile devices. So SQLite is very simple in terms of types. It just have three major types. In fact, there are four, but integer is for regular numbers, integer numbers. If you want floating pointing, you use real type, and for any kind of strings, you use text data type. Blob is to store array of bytes, but I think it's not good idea to store files or something like that in the database. I prefer to store the reference and use this reference instead. Okay, to use SQLite in Android, the best practice is use a subclass of SQLite Open Helper and override the onCreate and onUpgrade methods. In the onCreate, you have the database creation. So you have all the schema, all the database schema. So you create all your tables, indexes, views, or something you have in your database. And here I have just a simple example to create a table car just with model, plate, and year. And in onUpgrade, you use to upgrade your database. If, for example, if you launch the first version of your app, and in the second version you decide to add a column, for example, the car's color, for example. So it's not a good idea to delete the database of the first version and create a new one, because the user could add the information in the database. So the better approach is upgrade your database, adding this column to the card table in this example. So the upgrade is very useful when you want to update the database. So to insert a record is quite simple. You just have to instantiate the SQLite Open Helper version, the SQLite Open Helper object, get the database object, and create a content values object to mapping the column and the value. So here I have model, beetle, plate, blah blah blah, and year 1995. And I call the b.insert and insert in the table card. It's very simple. For update the record, I'll do almost the same, but I use the update method, and I have the where clause when I pass the criteria to update the record. And always remember to close the database after use the database. Okay, to deleting a record, you just have to call db.delete in the table car and with ID blah blah blah. Okay, it's quite simple. A simple query it starts to make the things more harder, because you have to call the db.howQuery or db.query, but I prefer the how query because it's more direct. So I have here select from car or model like question mark, and in this sample I want all the cars that starts with CO. And this call db.howQuery returns a cursor that is a result set with the values of each column of the result set. And I have to use the while to iterate over this cursor. And if I'm doing a map with the table and an object, I have to fill this object with the values that I retrieve from the cursor. So, and I have also to close the cursor after use it. Well, could it be simpler? An ORM maybe could be a good idea. And of course, the community create a bunch of ORMs. So we have Active Android, Oli, GreenDAO, DBFlow, ORMLite. Well, we have a lot of ORMs available on the market. But in 2015, I attended this event, the Android Dev Summit, and a friend of mine made this question to the in the fireside chat. Oh my God, fireside chat with the people from the Android framework. So this is what the question that he made.
First, thank you. It's about being with a lot of analysts here. So uh, today we can do a lot with the persisting API, but why don't we have a object relational mapper in
Wait,
the
I want to
actual API?
I want to do a quick poll. We were wondering about the answers. How many people think that we should provide something similar to an ORM or like anything on top, more abstraction on top of the database? Like, can I see hands? How many people think we should do this?
Who wants an Android ORM? Let's just be clear.
Count.
Seven? 10.
Okay, how many people say no because there's solutions out there? Yeah, I think this is kind of what we think too. So.
Well, I don't know if you guys see the videos in the correct time, but he asked if how many why we don't have a standard ORM in Android. This is a friend of mine, Marcelo, and he was his face in this event. But in fact, Marcelo was not happy. Marcelo didn't like the answer because because everybody knows that that's important ORM in Android. Well, much later, in 2017.
I want to say, okay, there should be some room for improvement. And we came up with Room, which is an object mapping library for SQLite.
So the same guy presented the room at the Google I/O 17, and I wasn't there, but somebody told me that the reaction of Marcelo was like that. Well, of course, we needed a ORM. But before we start to talk about room, let's talk about how the ideal ORM should be. This is another friend of mine, Ubidatan Soares. Sometime I asked him which ORM do he like the most. So he said none. All of them are bad because in fact, none of these ORMs are unanimity in Android. So if I ask 10 Android developers, I don't think all of them will answer this is my favorite, and all the 10 developers will do the same answer. So oh, we have a question here. Let me see if oops, I can see my mouse. Let me see. Okay, I have a question, but I don't know.
Oh, no, it's not a question.
Oh.
I just commented that Marcelo is also a GDE, and we should bring him to Mocria because he's very good.
Yeah,
Then you go the Ubiratã. So I said the Ubiratã is also a GDE and also very smart guy. You should bring him too.
yeah. I always said that Ubiratan is the best Brazilian GDE here, technically speaking, because he's great. Well, and in my opinion, in the Ubiratan opinion, an ORM must use annotations, use DAO approach to save and request data, has a query builder and validate at compile time the SQL instructions and autocomplete the SQL. Does not force me to extend a base class. This is it, uh, this is a comment for the Realm database. That is, yeah, because it forces you to extend the base class. Uh, the ORM must provide a support for Rx to have async access and provide support to programmatically do a migration. The same thing that SQLite OpenHelper does, it's good to on ORM has. Okay, some ORMs use the convention based to provide this migration. For example, put the file 2.sql in the assets folder and you are good to go. But you have no control for this migration. So I think it's not good. Okay, let's get started with Room API. To use Room, you have to add this dependency in the, not a dependency, but the Google repository in the projects build.gradle. If you are using the Android 3.0, you just have to put Google in Android 3.0. In Android 2.3, you have to put this Maven repository here. In fact, the room it's already in alpha 5. I forgot to update this slide. Yeah, and now in the module, the build.gradle module, you have to add these 3 dependencies here. The first one is the dependency itself. This implement keyword is replacing the compile keyword for the Android, the Gradle 2.4. I'm not sure. But in Android Studio 3.0, we are using implementation instead of compile. The capt is the annotation processor for Kotlin. If you are using Java in your project, you should replace this for annotation processor. And the Android test implementation is for unit integration tests. Okay, in Room, we just have 3 major components: the entities, the DAOs, and the Room database. The entities, the entities are the objects that you saved. So you define classes that will be persisted in your local database. The DAO is just a set of operations that you perform in your database, like insert, update, delete, select, and go on. So, and the Room database just provides database objects and define the entities that will be persisted. So it's quite simple. Okay, the entity, I have here a class called event. So a little bit of context. This event, it's an abstraction for an event that people can attend, like Google I/O or something like this. So in the event, I have the ID, that is primary key, and out generate. This is a thing interesting because in the realm we don't have a out increment field or something like this. You have to do this manually. We have the name field and the description, and I use this annotation column info to give the column name in the database. By default, the room we use the the field's name to the table column. So field name, we have the column name, and here description will become the DS, and the entity, the entity annotation has this indices that is an array of index that you can define in your entity. Very simple. You can define the table name using the table name property in the entity annotation, and you can use the primary keys property to define a composite primary key. If you have two columns, you can define a primary key with these two columns using this property, primary keys. The DAO, the DAO is very similar of the retrofit. If you are familiar with retrofit, that you just define the interface with the HTTP calls. Here in the DAO, we define this interface, and the implementation will be provided by the room. So I have this interface here, event DAO. The first method is annotated with insert, where I pass in the event object. And the interesting thing here is the insert method returns a long, that is the ID of the event that I just inserted. So if I have a master detail relationship, I can use the first insert to retrieve the inserted ID to insert the child records. I'm using this on conflict, so if I have some conflict on insert the record, the previous record will be replaced. The update returns the number of rows affected by the update. In this example, it's just one, but the delete receives a vararg of events. So you can pass a list of events or how many events you want. Important is the insert, delete, and update can receive vararg arguments. Okay, so you can pass a list of events in the insert and update. Now I'm I'm telling this. I don't know what's the behavior of what's the insert will return once I insert a lot of events. I have to test this. Okay, but the last two methods are two selections in the database. The first one, it's events by description, where I'm selecting the events by the description. But the interesting point here is I'm using the arg0 as parameter. And the parameter itself, it's called description. If you are using Java, you don't have any problems. You can use column description in the SQL instruction. But in Kotlin, when you compile the code, this description parameter becomes arg0. So this is a bug registered in Kotlin and in Room. This is a bug registered in both Roam and Kotlin sites, but for now I don't know if the people resolve this issue. Okay, and this method returns a list of events, and the second one, the last one, returns just one event. Okay, so and in the query I can return a list or just one object. General rules of DAO, I already told you. The insert, delete, and update can receive one or many objects. A query can return one or many objects. This is the last one is important. If the object properties contains the same column set returned by the query, based on their names, the room can resolve it. So if your query is returning 3 columns and the object has has these 3 columns as well with the same name, you are good to go. The room can resolve it. Okay, the database, as you can see, is an abstract class that extends room database. And in the annotation, I list all the class that I will persist in my database. I define the database version as well. And I just have one method that provides me the event DAO. It's very simple. This is an example of how to use the room. The first thing is get the instance of the database using room.databaseBuilder, passing a context, the room database subclass here, the database name, and call the build method. Once I have the db instance, I call db.eventDAO, and I get the DAO instance. I can create the event object and call DAO.insert. Once I have the ID, I can retrieve the event by ID, just a test, and print the information. I can also use the events by description and list each of the events. It's very simple. Incompatible types. For example, if I define a date of the event, the room will not resolve this field because the SQLite doesn't have this data, this date type. So I have to create a type converter. This type converter just, as the name says, converts a date to a long and a long to a date. So in my database, I have to define these type converters. To be honest, I don't think in any other type of conversions you can say, oh, I can have to have a conversion for Boolean, for example, but you just use 1 for true and 0 to false or something like that. But I think almost the common types that you have in the database you can. Well, but if you need, you can define a type convert. Embedded fields. In my event class, I can use a address to define a location of the event. And in this case, in the table event, I will have 3 more columns. I will have the event table with the fields, with the columns ID, name, description, date, and street, state, city. So this embedded annotation is creating this all the columns defined in the address class. Okay, it's a relation, one-to-one relation. Foreign keys. This is a complicated topic. I don't know if I will explain very well, but well, in the event, I can have several tracks. For example, at Google I/O, I can have a track for Android, and I can have a track for Firebase. I can have a track for design or something like this. And so I define a class, an entity track, that has a primary key with ID, name, and the strange thing is event ID. And I define a foreign key of track with event. I say I have a foreign key with event class. With the parent column is the ID, the event's ID, and the child columns is the event ID in this class. I'm using this onDelete to describe, to define that when I delete an event, the tracks of this event will be deleted as well. So the ideal design of this class will not contain this event ID. in fact, if we don't have a persistence, this event ID will not exist. But why the guys, the room engineers decide to use in this way? Well, there is an issue for foreign keys that is, should I load the children records? For example, if I want all the events in my database. When I retrieve the events, should I load the children records? I should load the tracks. You can say yes, okay, load the tracks as well. But if the track has, for example, an organizer, the people that organizing this track of the event. So I will have an object called person. So when I load the events, I should load the organizer that is a person. And if a person has some childs, and so on. So you can say, no, you don't have to load the tracks. You just have to load the events. And I will load the tracks when I call event.tracks, for example. So the most of the ORMs or other libraries using this lazy loading approach. But it's not good in Android, in the opinion of the room engineers, because when you call event.tracks, for example, you are doing this in the main thread. So this is not good in the implementation way, because you are loading things in the main thread that it's become your application laggy. You are losing frames because you are doing this in the main thread. So how can you use foreign keys with room? Well, here I define a track DAO to insert tracks and retrieve the tracks by event. In the event class, I define a field called tracks, but notice that this field is annotated with ignore. So this field will not be persisted. And in the other class, for example, in my event database, or a new layer that you can put between your UI and your database, you can create an event object with the tracks. So I can use event.dal to retrieve the event information, and I can use track.dal to retrieve the tracks information. I don't know if it's clear, but it's not perfect, but I think this gives more control to developers. So I like this approach, to be honest. Smart join. I don't know if the title of this slide is correct, but the big thing here is I'm doing a select in the event, in the event table, and getting the number of tracks on for each event. And I define this in a new column called numTracks. But this column numTracks doesn't exist in the event class. So I create a subclass of event and add this field, numTracks, and you are good to go. And the room can resolve this for you. As I said before, if the columns returned by the query matches with the properties in your class, room can resolve this mapping. Migrations. If you decide to add a new column, in this case capacity, you have to be allowed to keep the existing data in the database and add this new column. You can do this using migrations. You just have to create a object migration. In this case, I'm creating a migration from version 1 to version 2, and just executing the SQL related to the changes between the two versions. I'm adding this new column to the event table. And when you get the database instance, you have to add these migrations on the database call. In fact, it's a good idea to keep this second call here in a separated class, and all the other points of the app call the same place to guarantee that you are using the correct instance. Another good thing is Room provides access via RX2, RX Java 2. You just have to add this dependency. The first dependency is related to Room. The other two is from the RX Java 2. So you just have to, if you are using RX Java, you just have to put the first one. So in your DAO, you just have to replace your list of event for a flowable list of event as the same you using the event by ID, and you return a flowable of event. You can use maybe and single too. This is components of the RX2. To use the RX, you just have to call DAO.events by description, subscribe on schedulers.io, observer on main thread, and subscribe. This is very simple. One thing that I didn't say before, you cannot, by default, you cannot use Room in the main thread. You must you have to use another thread to insert information on the database. So you can use async task or something that you prefer. Particular, I prefer RX. For testing, I just put here one important thing for database testing, that is in-memory database builder, that you are creating a memory database. So every time that you start the thread, you start the test, you have a clean database. You don't have to clean the database before execute the test. So every time you start a test, you have a fresh new database. I said before that you cannot use Room in main thread, but if you really want, you can add this method here, allow main thread queries, but please don't. And always remember to close the database. So to finish the presentation, Room uses annotation instead of reflection. This is good. Uses DAO approach. That's good as well. It validates the SQL in compile time. This is fantastic. If you are something wrong in your SQL, the Android Studio will show you a compilation error, so a compiler error. So this is very interesting. The Room does not force you to extend a base class, provides support to RX, and supports programmatically migration. So this is some references. The Room persistent library. This is the official documentation. I wrote an article about a blog post about Android architectural components. I didn't say before, but the Room is part of this Android architectural components launched in the Google I/O 2017. And in this post, I have all these components working together. We have view model, lifecycle, and Room working together. And this is the third bullet is 7 Steps to Room by Florinda Montenesco, that is a Google developer advocate. There is another interesting post from Florinda that is testing migrations with Room. She launched this. She's published this post yesterday, I think. But it's nice to know how to write tests for migrations. And the last one is slides from Rodrigo Castro. This is a Brazilian guy too. Yeah, that's it.
Nice.
Questions.
One question that comes to mind immediately is, do you find any link with performance metrics? You know how every time there's a new ORM, they like to say, yeah, we can do more writes or more reads
Uh, I
on
didn't
Realm,
I, I,
stuff like
di-
that.
I didn't perform a benchmark, but once I need to, in a project in the past, I needed to add 5,000 rows in a same insert. I have a bunch of records to insert at once. And with room, I in this sample, I inserted 5,000 records, and it spent 1.2 seconds.
1.2. Okay.
Yeah, it was good. Yeah, it's not bad.
Cool.
More questions. Douglas, did you understand my Brazilian English?
Better than what's that guy from Google?
Igit.
Not much.
Ah, okay. Okay, thanks.
But in fact, the only question I had was the same one Pablo already asked. Was about performance, but so uh, I don't have anyone.
Yeah.
Ah, Room for now it needs the new Gradle plugin that if I
Um,
remember correct, right?
y-
I mean, you can't use Room with Android Studio
2.3.
2.
Yeah,
Yeah.
you can. Yeah, you can. You just have to add the Google repository, and you are good to go.
Ah, okay. Don't need to use Android Studio
3.0.
Canary.
Yeah. In this sample, I did with Android Studio 3.0, but I think I started this example in Android 2.3.
Okay, yeah, I noticed because you use it implementation instead of compile
Yeah,
for the dependency.
yeah.
So that's the new.
That's weird. This implementation. I don't know why the people. In fact, I read about this change, but it's compile is more clear for me. Compile with this library. I don't know.
It's because they divided compile versus implementation versus API because compile exposed APIs transitively. So if library A depends on B and B depends on C, A could see
See.
the C API.
Yeah.
Uh, that way, if B stopped using C and start using anything else, A would break because C will not be available anymore.
Okay, got it. Yeah. So, um,
So the implementation uses SQLite, right? In the bottom,
yeah,
I
this
file system.
this
Yeah,
is a ORM over SQLite.
yeah. Oh, SQLite. Yeah, cool, cool,
Yeah.
nice.
Yeah, I want to test someday the difference from use this and use Realm because Realm has had a lot of improvements later.
Mm-hmm.
So, for instance, that complained about need to extend some base class. Not anymore.
Mm-hmm.
Realm, it was in the first versions. And
Mm-hmm.
Realm has a really good performance. But if you can use the native SQLite without the boring parts of the boilerplate of SQLite, so that's good.
Yeah, I tried the Realm sometimes, but I didn't. I think I don't like the the NoSQL database. Even the Firebase. When I look at this big giant JSON, oh, that sounds weird to me. Well, so I think this is what I have
was great. Thank you, Nelson.
Thank
Nice
you.
presentation.
Thank you.
Thanks.
Thank you, guys. I'll finish this recording here.